Hello, 8th graders. Today we're going to be working with direct variation. If your I can statement is not listed on your notes, go ahead and take the time to write that down for me, please. I can use a direct variation equation to determine the unit rate of a proportional relationship. So basically, we're going to be finding the unit rate so that we can do something with that. We can determine another number. Direct variation, you remember, is a function in the form y is equal to kx. We're familiar with that. And the constant of variation for direct variation is the k. So k is the coefficient of x. And so k means the constant of variation or the unit rate. Write an equation of the direct variation that includes the given point. So each time you do a problem today, I want you to write the equation. The equation is y is equal to kx. So we're given an ordered pair. That's what it means by going through the given point. And we know that 4 is the x and negative 3 is the y. So we're going to just simply substitute that into the equation. That's why I want you to write the equation. The equation is y is equal to kx. So x is 4. So I'm going to substitute that in for x, and then y we know is negative 3, so I'm going to substitute that in. Now, as far as the equation is concerned, we are much more familiar with having the variable after the number. So I'm just going to rewrite this as negative 3 is equal to 4k because we know that the 4 in front of the k is the coefficient, and we also know to divide by that. So I would just suggest at least through the first couple of problems, maybe switching that so that you know what to do with it. Because now we know that this is an equation. Negative 3 is equal to 4k. We know to divide through by the coefficient. And we may not have recognized 4 as the coefficient in that because it just looks a little different. Once I solve, then the 4's cancel. All that's left is k is equal to negative 3/4. I'm going to switch that around. Notice that my equal signs are lined up. You've heard me say that before. Our equal signs are lined up. And now I know that my constant of variation or my unit rate is negative 3/4. So once I know k, then I can go back into the original equation, which was, once again, y is equal to kx, and we can substitute in negative 3/4 for k. Y is equal to negative 3/4 x. And that, my friends, is our final answer. We have written an equation in the form of direct variation y is equal to kx. So we need to use the points given, the ordered pair given, in order to write that equation. So in this particular problem, all we're doing is writing the equation. We're not doing anything else with it. We're just learning how to write the equation. We're going to do the same thing in this example. First step, write the equation, y is equal to kx. So write an equation of the direct variation that includes the given point. In this case, our given point is negative 3, negative x, where negative 3 is x and negative 6 is y. So we're going to substitute that in. Negative 6 is my y. I don't know k. And then negative 3 is x. And once again, this just kind of looks funny. It's k times negative 3. So I'm just going to switch that around, because I know how to solve an equation when the coefficient is in front of the variable. So I think that just makes it a little bit more comfortable for us. Now we know that we always divide through by the coefficient, or in this case, negative 3, and we want to do that on both sides of the equation. Negative 6 divided by negative 3 is a positive 2, of course. The negative 3's just cancel, and then all that's left is k. And I'm just going to switch that around so that my final statement is k is equal to 2. Once I know my constant of variation, then I can substitute that back into the original equation, y is equal to kx. So our k is 2, y is equal to 2x. Final answer. Now, in the next examples, we're going to do the same thing we just did, but we're going to do something with it. So once I have the equation, then I can use that constant of variation to find a missing term. So we want to, it's kind of like using what we know to figure out what we don't know. So y varies directly with x. That tells us that write an equation for direct variation. When it varies directly, that means it's proportional. That means that it's traveling, it's the same rate of change, it's the same unit rate. So once we know the equation, then we can use that equation to determine the missing value. And you're going to notice in these problems that the numbers are kind of scrambled, but where you see x and y together, then we want to use that as our first step. So I'll show you what I mean by that. It says if y is negative 12 when x is 9, find y when x is negative 4. So we definitely know this part. We know the left side of this statement. If y is equal to 12 when x is equal to 9. So I know my equation, write it each time. Y is equal to kx. So y is negative 12. We don't know k. That's what we're going to try to find. And we know that x is 9. Once again, I've got negative 12 is equal to k9, so I'm going to just switch that around to put the coefficient in front of the variable, and now I can solve. When I solve, then I divide through by 9, so k is equal to negative 12 ninths when simplified, because if I divide by 4, then I would end up with negative 4 thirds or 1 1/3. Either one of those answers is okay, but do make sure that you simplify negative 12 ninths down to negative 4 thirds. Now, once you have negative 4 thirds, then I can substitute that in and create the equation, just like we did in the first two examples. So we've got y is equal to negative 4 thirds x. Once I have the equation, then I can use the equation to find the answer to the second part of this question. So it says find y when x is equal to negative 4. So if our constant variation is negative 4 thirds, or our unit rate is negative 4 thirds, all I have to do is go back and substitute in the part that I know to figure out the part I don't know. Well, it says find y, so I don't know y. And I'm just going to use the negative 4 thirds, and then x, in this case, is negative 4. So y is equal to 16 thirds, also known as 5 1/3. You can leave it as an improper fraction. That is totally okay. And once I have my y, then I can go back and check to see if my proportion is correct. My proportion meaning, because it's a proportional rate. So to begin with, we had 9 as x and 12, negative 12 as y. That breaks down to negative 0.75. Okay, so if y is 16 thirds, so we have to use that proportion. So when x was 9, then y was negative 12. I'm just going to use x on the top and then y on the bottom. So x is negative 4, then y is over 16 thirds. And if I put that in my calculator, then you may have guessed it, it's also going to break down into negative 0.75. So all I'm trying to do in this case, you guys, is just to give you a way of checking your answer to make sure that the proportion is correct. All right, so y varies directly with x. Write an equation for the direct variation, then find the value. So we've got two parts. I can see a comma. Right away it says find x when y is 25, if y is 7 when x is 8. So the two parts, here's my first part, which says find x. So obviously I don't know everything I need to from that statement, but I do know everything that I need to know from this second statement. Step 1, write the equation. Step 2, substitute in what I know so I can find the constant of variation and then use that equation to find the missing x. So if y is equal to 7, I'm going to go ahead and substitute that in for 7. I don't know k, and I know x is 8. I'm just going to switch that around so it says 8k because I know that I should divide through by the coefficient to solve this problem. So k is equal to 7/8. From here, I need to write the equation. Y is equal to 7/8 x. Okay? Y is equal to 7/8 x. Now that I have the equation, then I can use the equation to find out the missing part. So it says find x when y is 25. So 25 is equal to 7/8. I don't know the x, so I have to solve for the x. Well, when I have a fraction in front of the coefficient, then I multiply by the reciprocal. That's how we solve. Remember, we talked about that. Looks kind of funny if I try to divide through by a fraction. So you always just show your work by multiplying by the reciprocal. And when you multiply by the reciprocal, then you're going to end up with we end up with 28 and 4/7, also known as, you can leave it as an improper fraction, it's okay, 200 over 7, or that's 28 and 4/7. Now remember, if you want to check your work, then you can do a little check. So originally we had 8 is to 7, so that should be proportional to my x, which was 200 over 7, and that's compared to 25. You can just change both of those into decimals or into fractions, and you should get 1 and 1/7 for both of those. Oh, and I skipped one. If you want, we'll go back to this one. I thought I was off a little bit. So y varies directly with x. Write an equation for the direct variation, then find the value. Find y when x is 10, if y is 8, when x is 20. So I'd like you to pause the video and do this entirely on your own. When you are finished, then check your work. You can start with writing the equation. Y is equal to kx. So find y when x is 10. This is part of the equation. This is part of the equation. This is the part I know. I don't know y on the other side. So I'm going to substitute in what I know to figure out what I don't know. So y is equal to 8. I don't know k. X is equal to 20. I'm going to just do a little switcheroo here. Divide through by 20. And so I end up with 8/20 divided by 4 would be 2/5 is equal to k. So k is equal to 2/5. Once I have my constant of variation, or my k, then I can write that in an equation. Y is equal to 2/5 x. Now I can use that equation to determine the missing part. I don't know y, and x is 10. So that means y is equal to 4. Feel free to use your calculator too. ABC 5 times 10, and that's going to give you 4. If you're checking your work, then 10 is to 4. 10 is to 4 as 20 is to 8. You can change them into decimals. You can also use cross products. That's another way to check your work. So 4 times 20 gives me 80. 10 times 8 gives me 80. So that does, in fact, check. So the goal there was to determine the value of y using the constant of variation, writing the equation, and mission accomplished. I hope you enjoyed learning how to write an equation in direct variation today.